So we said, today we're talking about experimental versus theoretical. Okay, so first of all, I want you guys to type in the chat real quick. Experimental and theoretical. Let me know if you've heard those words before, or if you think that experimental looks like something you've seen, a word you've seen, or theoretical looks like a word you've seen, or both. So in the chat, take about 10 seconds, say, have I heard those words? Does that sound like something I know? And respond in the chat. Okay, we've got some saying they've heard of both or seen both, not quite sure what it means. Okay, good, good. Keep them coming, guys. So, what about experimental? What does experimental kind of look like? What kind of word is maybe almost in there? In or almost in? Well, that first part right there, exactly, is experiment, right? So just like experiment, you guys have heard before, hopefully, in science, it's the same word, it's just as an adjective. So experimental. So this probability is going to be like an experiment. Okay? This probability is going to be like an experiment. And then this other one that we have, theoretical, this kind of looks like the word theory, right? So if you were thinking, hey, that kind of looks like theory up front, that's exactly what it is. So this is probability dealing with a theory. Okay, so this is like, I think this is how this should work. And then an experiment, as you guys hopefully know from science, is like, I think this is an idea, I'm gonna try. Try. That's it, experiment, right? Alrighty, good job, guys. So last week, we talked about figuring out simple probability on a scale of impossible to certain. So, we said, what's the probability of this thing happening, an event happening? And we said, well, maybe it's impossible, there's no chance it would happen, or we say it's certain, it's for sure going to happen. For example, if we said, what's the probability that the sun is going to rise tomorrow? Well, we'd say, well, unless something crazy happens, right? That's certain. That's 100%, right? Or a 1.0, if we're talking about as a decimal, or a 4 out of 4. If there's other possibilities, there's 100% chance it's going to happen. Okay, impossible would be 0, right? And yeah, and let's say one other one, and I'll ask you guys where you think it would be on this scale. I want you guys to respond. So this is calling back to what you learned last week. What would be on just the scale of impossible, unlikely, as likely or not, likely or certain, or if you want to use a percentage, you could do that too. I want you to type in the chat and tell me what's the probability of us having a Zoom chat at 9 on Wednesday. So what would be the probability that we're going to have a class Zoom chat Wednesday at 9? Real quick, fill up the chat. Got a lot of people saying 100%, certain, good. Okay, good. Awesome. All right, I've got another one. What's the probability or possibility of there being rain sometime this week? A full-on rain. What's the probability that there'll be a full-on rain this week?
When you say full on, you mean like raining everywhere, coming down?
Yes, you're right. I should clarify. Rain over, let's say at least half the. Okay, that's probably a good rainstorm. So at least half the valley full of rain in the next week. Good. I like all these answers. Some people are saying 50%, a fourth, maybe unlikely, probably, likely. Good. Yeah, all those could be true, right? And then if we got more information, like, oh, there's a forecast for rain, or maybe there's not a forecast for rain, that can help us figure out our probability. Good, guys. Excellent. All right. So theoretical probability, this brings us today. Theoretical probability is the science of what should happen. Okay, so in theory, this should happen. So, like, for example, if there was a forecast for rain on Tuesday, we'll say, well, theoretically, there should be rain on Tuesday, but sometimes it doesn't always work like that, right? Sometimes it goes a different way, things like that. So I want you guys to read this line here up on the screen. You can read it out loud or in your head to yourself. Theoretical probability, it's written like this. And then say the number of ways the event can occur divided by the number of equally likely outcomes. So the number of ways the event can occur divided by the number of equally likely outcomes. Okay, so basically the total possibilities, okay, divided by all the equally likely outcomes. So notice this does not require the different outcomes to be fair. Okay, so let's go ahead and see what this would look like in action. Okay. So on your sheet, you've got your Google Draw sheet that you can use, hopefully. Or again, when in doubt, you can always use a piece of paper. Okay. All right. So this says, we got a little coin here, right? Penny. It says, what is the sample size of the coin? What is the sample size of the coin? So I'm going to do this one, and then I'm going to have us as a class kind of look at these other two. So I'm going to pick.
Can I make a quick comment?
Yes.
You guys are all going to be doing some of this on your own, but for right now, we're going to just talk about the possibilities. So you don't need to have these things in front of you, but later you will be doing these, whether it's on a digital coin or a digital dice. You're going to be doing this on your own, but for right now, we're just going to talk about kind of the possibilities.
Good. Thank you. Thanks, Mr. A. All right, so the sample size, again, if you go back to our last unit that we had at the school building, a sample is like a small portion of something, right? Or what you're looking at. So in this case, what is the sample size of the coin? Basically, what are the total possibilities? How many different sides are there to this coin? Well, we'd say, well, a coin, of course, it's two sides, right? Two sides to a coin. And how many heads are there, though, on a coin? We know there's two sides, but how many heads? There's only one, right? If it's a normal coin, give them a little eye there. Be surprised. A little beard. All right. So there's only one head side, right? Heads and tails. So one head side. So probability of heads, if we're following this right here, number of ways the event can occur. Sorry. Let me back that up. Number of ways the event can occur. So probability of getting heads. It can only happen one way. So we put the one on top. Okay, and then the total possible outcomes. Okay, or the equally likely outcomes. There's two equally likely outcomes. It's just as equally likely to be tails as it is heads. So the sample size is 2, and there's only one head. So 1 out of 2. So as a decimal, 1 out of 2, hopefully we know that's 0.5, because that's a common one, right? And as a percent, we move that decimal place 2 spaces over, and that gives us 50%. Oops, sorry. My drawing today is not up to snuff. All right, 50%. So you can be drawing this on your sheet. Hopefully yours is maybe a little bit neater than mine. All right, so even though this is kind of wordy, I don't necessarily like the way this is worded. It's basically the total number of ways of your event occurring, in this case, just heads, over the number of equally likely outcomes, the total possible outcomes. So there's only 2 outcomes, but that's going to be on the bottom, and then what we're trying to see is going to happen, like heads, is going to be on top. Okay, so what I want you guys to do now is we got a little picture of a die here. If you didn't know it, it's technically dice if you got several of them, and it's a die if you got one. So on this die, what is the, or Mr. A called it a number cube the other day too, so that's another name for it. So we've got a die here. It says, what is the sample size of this die? In the chat, I want you guys to spam the chat with the answer to that question. What is the sample size of the die? How many possibilities are there? Total possibilities. Just real quick, hop in that chat. Good, I'm seeing a lot of 6. Hopefully so. Good job, guys. All right, 6. How many faces of the die have a 3? So if there's 6 sides total, and you can draw this on your page. Now, how many faces of the side have a 3 on it? Go ahead and put that in the chat. Okay, nice, good. I'm seeing a lot of 1s. Good, guys. Yeah. So if this is a 6-sided die, that's usually what they come as, like a box shape. And how many faces of the die have a 3? Well, there's only going to be 1, because if you're familiar with dies at all, one side's got a 1, one side's got a 2, 3, 4, 5, and 6. So there's 6 sides, and they each have a different number. All right. Now, what's the probability? So this says P parentheses roll a 3. That says, what's the probability of rolling a 3? What do you guys think? What's the probability of rolling a 3 on the 6-sided die?
It's going to look like a fraction.
Mm-hmm. You're going to write it as a fraction. And remember, we want the probability of what we're looking at, the total number of ways for our outcome to happen, over the total possible outcomes. So no fear, no judgment. Post what you think in the chat. Get the discussion rolling. Yeah, I see a lot of people pretty close.
No.
Okay, so that is correct. There's one way to roll on a 6-sided die, right? Out of 6 total possibilities. 1, 2, 3, 4, 5, or 6. So that's going to be 1/6. You're exactly right. And then as a decimal, let us see what we got here. I don't really like this. Anyways, I thought I did. Sorry. There we go. So 1/6, and you can always double check yourselves. What did you guys get? Say 1/6 is kind of ugly, right? It's like 0.1666666. So let's say we're rounding to the nearest hundredth. So 10th, 100th, and then that's where we round. So 6 is going to round this guy up to a 7. So let's say 0.17. So as a decimal, about 0.17. We rounded, so that's not perfect. That's not exact, but very close. And then as a percentage, again, we just move our decimal place over a couple spaces, so about 17%. Alrighty. So this one I want you guys to do. Okay. So here we've got a little spinner. Okay, it's got all these pretty colors. What is the sample size of the spinner? So it's going to ask you how many different possibilities there are, the sample size, and how many sections are yellow. Okay, and then it's going to ask you about that probability. So I want you guys to go and try to fill this all in. You don't have to, you don't have to respond in the chat just yet. Okay, and I'd ask that you actually refrain from doing that. And I just want you to fill in these answers / find them out.
All right, while you guys are doing this, I'm going to show you what this should look like on the Google Draw file. Mr. E, could I steal the screen from you?
Yes. Okay, all those yellow. There we go.
Okay. So in the Google Draw file, and I think we had it set up so you guys could actually go in and edit this. So, whoops, you will have to make your own copy of this, so you can share it after you have all of your own personal answers. It looks like we already have all the answers for what we've done so far, besides what we're doing right now. So in the Google Draw, you can go ahead and double click into these boxes and type in your answer. So like in the cube, we have a 6 and we have a 1. And then in this box, I'll type a 1 out of 6, or 1/6, or 1/6. And you'll have to do that with the example that we're doing right now. So what is the sample size of the spinner? How many sections are yellow? So if you haven't yet, please right now make a copy of that real quick so you can put in these answers that we're doing together, or sorry, that you should be doing on your own right now. We'll talk about them in just a minute after we give you another minute to do them on your own.
All right, so that draw file, short version, make a copy of it so it's not all just one sheet, and then it'll allow you to write on it. Thanks, Mr. E. I'm Mr. A.
That's funny. I can see Morgan in Alexia's camera.
Nice. That's funny. Good. We'll say about 20 more seconds in case you were making a copy of that file. Five more seconds. 3, 2, 1. Fist. All right. So what I want you guys to do now is go ahead and put your percentage answer. Aha! Didn't expect that. Percentage answer in the chat. See what you guys got.
Do you want to open up that sheet again so we can see which box?
Yes. Good idea. So that's going to be this last guy here, right? What would be the probability of stopping on yellow as a percentage?
Got a couple answers so far. Nice. All right, we got our first percentage in there.
Good. Good, guys. About 12%, 13%, 10%. Good. 11%. Awesome. And you can keep posting those in, Mr. A. I'll keep checking those. Good. So let's go ahead and see what we should have had here. So sample size of the spinner. Okay. Sorry. So let's see how many spaces there are. There's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 possible choices, right? So if I flick the spinner, and it lands on a space, there's 8 possibilities. So the sample size is 8. Okay. Now I say, how many sections are yellow? Well, there's only one section that's yellow, so there's only one way to spin a yellow. All right. So then we say, okay, what I'm trying to get over the total number of possibilities. So 1 over 8. So probability of stopping in yellow is 1/8 as a fraction. Okay. As a decimal, I always take my handy dandy calculator and say 1/8 is 0.125. Okay. So 0.125. Okay, and then if I need to make that a percentage, I move my decimal place over 2 spots, signifying that I am having this out of 100. So I've got 12.5%. Okay, now if it said to the nearest whole percent, all you guys that said 13, you would be correct. It would be 13%. If it ends, if it's a terminating decimal, like we have here where it's just 0.125 in the stop, and it stops there, then go ahead and just make your percentage 12.5 because we have the whole thing. So 12.5% is the probability of spinning a yellow on the spinner. Alrighty. Let me pause real quick. Any quick comments or questions? If you have any, you can put it in the chat or say mic if you need to ask a question with the mic. Okay. Mr. A, let me know if there is one. All right. Otherwise, we're going to experiment. Okay. So we talked about experimenting is just like the word in science. It's the same word. So experimenting is this idea of trial and error. Okay. So if we think we have a theory or how something's going to work, the only way we'll know for sure it's going to happen, right, is by testing it. Okay. And the more tests, the better, right? If and this kind of talks about. Oh, Mike, I'll pause real quick. But this kind of talks about the population and sample stuff that we were talking about in class before we did distance learning. Okay, Jorge, you can unmute your mic for a sec if you have a question.
Who is tired of quarantine?
Okay, math-related questions only right now, though. All right.
Me.
Okay.
I love this vacation.
Any other math-related questions? I don't know where my little box went. Oh, there it goes. Okay, Jonathan, do you have a question? Okay, or Jure. All right. Then for now, okay, if you have any questions, you can post them in the chat. Mr. A will be able to answer for you.
I don't get the spinner question.
Oh, yes. Question?
He said he doesn't get the spinner question.
The spinner question. Okay. It should have a little black spinner on it, honestly. If it's being realistic. So if you've never seen it, like think of like maybe Wheel of Fortune or like some board games and stuff will have like a little spinner. And we'll actually look at one here in a second class. But it looks like this, right? It's got a little arrow. And you flick the spinner with your finger and it spins it. And it lands on a space, right? So if we do that, that's a random answer, right? But there's 8 possible spaces it can land on. Blue, green, yellow, red, etc., right? Well, there's only one of those wedges that's yellow. So that's why we said there's one yellow section and there's 8 total possible color sections. So then we say, okay, what's the probability of stopping on a yellow? Well, 1 out of the total 8. 1 square out of the total possible 8. Does that kind of hopefully clarify a little bit?
Yeah, I understand it now. Thanks.
If you were in my class, we had a spinner that we would use to choose random names. So for that instance, let's say we had 20 students in the class, and if you are only one student, then you would have the chance 1 out of 20 to be chosen on that spinner. So that would be a different fraction. That's a different spinner. It had a lot more sections, but it works the same way. You have to find the sample size, which is the total number of possibilities. For this sample, we have 8 different colors. So that's 8 different possibilities. And this is asking, basically, what are the chances it's going to land on yellow? Which is 1, because there's only one yellow section.
Oh,
And so the chances of landing on yellow would be 1 out of 8 possible colors.
Exactly. Okay, so hopefully that helps. If you have more questions, we can answer them as we finish later. So experimental probability. Okay, so we talked about theoretical. This is all theoretical. Experimental is, again, like trial and error. You practice, you try it, and see what happens. So this is the science of what did happen through observation. Okay, so what actually did happen? Experimental probability. So the probability, you write it the same way, capital P, parentheses, what the event is. And this is the observed frequency of the event over the number of total attempts. So I'm going to actually write this because I want to write this kind of in layman's terms. So the theoretical probability that we had, right? Theoretical, I'm going to just abbreviate. Actually, I'll write it. Theoretical probability was the possibility, the ways of getting, I can have a text here. Ways of getting our desired outcome. In that last case, it was yellow. And this is too slow, sorry. So I might just have to pause. I'll just say it out loud. Ways of getting the outcome that you want, in that last case, the yellow, over the total possibilities, just in general, right? There was 8 total possibilities. So you would have the ways of getting your outcome that you want out of the total possibility. And then probability as an experimental probability is if you try it a bunch of times. So if I tried it 10 times, 10 would be my total. And then the observed frequency of the event. So you would say like, oh, 3 times out of 10, I ended up getting yellow on the spinner. So, and this is how it relates to what we talked about with population and sample, guys. The more experiments, the more accurate it's going to be. So if if I only ask 10 students, so right now, I want you guys to, in the chat, you can tell me whether you like meat and cheese better or you like peanut butter and jelly sandwiches better. You can answer that in the chat. Do you like peanut butter and jelly better or meat and cheese sandwiches between those two choices? Now, if I ask 10 Westlake students, or I asked even this Google chat, this Zoom that we just did, what your favorite sandwich was between those two, we'd get some of our answers here, right? Like some of you guys said, we got a peanut butter and jelly. Okay, good. I've got a couple peanut butter jellies, like a meat and cheese, peanut butter and jelly. So now, is that going to be more accurate, or is it going to be more accurate if I asked all of the 7th grade?
Hello, what's a meat and cheese?
Would that be more? That's like a ham and cheese sandwich, or a turkey and cheese, some sort of meat. All right, so which is going to be more accurate? Is it going to be more accurate with a small group or a big sample? I'm trying to figure out what Westlake likes. It's going to be the bigger group, right? So the bigger the group, the more accurate, all right? If I only asked 10 of you guys what your favorite sandwich was, that's not going to be as accurate if I asked the whole school or if I asked all of the 7th grade. All right, so this works even when fairness cannot be guaranteed. So I want you guys, there's a funny little video, okay? You guys can, you can watch this here in a sec because we're going to give you guys, I'll post the link here too. And watch this video that shows kind of the problematic issues with flipping coins, maybe some frustrations with it. And then after this video, or while you're watching this video, I want you guys to get a coin, okay? Any coin. It can be penny, nickel, dime, quarter, peso, anything, okay? Some sort of coin that's got two sides, a heads and a tails. So get that coin, watch this video. I'm gonna go ahead and actually play it on my screen maybe too, in case you have maybe an issue with getting this set up. I just had it. Okay, there's the link, or you can watch along with us. Okay, so this is just kind of to take a little mental break. That was a lot of talking.
When you shared your screen, did you set it so it'll share the computer sound? Because there's a little checkbox you have to click. I don't hear your sound.
Let's try this again.
It should be in the bottom left.
Okay.
I'm bored.
Mm-hmm.
I can hear it now.
You want to do something?
I am doing something. Go bother Mom.
Do you mind you guys in quarantine?
Hey, I'll bet you $1 this coin will land on heads.
Okay.
Ha! Heads! $1.
Flip it again.
Fine. I call heads again. Ha! Heads! That's another $1.
Double or nothing.
Fine. I call heads. It's heads. And since we're doing double or nothing, I believe you now owe me $2 more. What should I do with my $4?
All right, flip it again.
Double or nothing?
Double or nothing.
That's another $4.
Just flip it.
Heads.
Seriously? Again.
Heads.
Again.
Heads.
Again.
Tails.
Really?
No, it's heads. You owe me $64. You keep doubling it. It's not my fault.
Oh, I see what's going on here. I'm being hustled, aren't I? That's a trick quarter. Flip it again. This time, I'm taking heads.
It's tails. That's $128.
I know what it is.
Maybe we should stop. You already owe me more money than you make in a week.
You're right. I just need to walk away. Or I need to vary my approach. Keep flipping it.
Matt!
Just do it. Heads.
Tails.
Tails.
Heads.
Heads.
Tails.
Tails.
Heads.
Heads.
Tails.
Tails.
Heads.
How much?
$8,192.
Clearly, that strategy was flawed. Okay. Give me another coin.
Matt.
Just give it to me. We will both flip these until one of them lands on heads. It's bound to happen. Tails.
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 Tails! Fine! I now choose tails! Heads! Ah! This is the most statistically amazing thing I have ever seen.
In case you're wondering, we're now at $536,870,912.
That's it. My life is over. This 2003 special edition Arkansas quarter has ruined my life. I'm done. Let's work up a monthly payment plan.
Why don't you try flipping it one more time?
Why? I'll tell you why. Because if I guess wrong, I will owe you $1,073,741,824.
We're really good at math.
Right?
No, come on, one more. I've got a feeling.
I'm scared.
Heads or tails?
Tails.
It's heads.
Ah.
Come on, one more.
No, it doesn't matter anymore. Don't you see? My life has crumbled before my eyes. My children's children will be paying off this debt to your descendants for centuries.
Heads or tails?
I refuse.
Heads or tails?
Heads!
It's heads. Matt, it's heads.
Heads? It's heads. Oh, President Washington, your face is so masculine. Oh, I'm free. The air is sweeter. The colors are more vibrant. This pizza is still very old. Oh, I'm free. I'm free. Oh. Okay, $1. Heads or tails?
All right. So, you're following that along. Pretty funny. Albeit a little silly. I hope maybe you guys can relate with some of the quarantine of like, all right, let's flip this coin. And in his case, he just got really unlucky, really bad chance. Like, again, the chances of him flipping those and always getting it wrong is pretty amazing, right? So, you should never gamble. Accurate. All right. But that shows you kind of experimental probability. And let me pull up my screen here. So the likelihood of that happening, okay, the probability, in theory, the theoretical probability is just 1 out of 2, right? 50% chance. So theoretical probability is 1 out of 2, 50%. But the experimental probability for him, it was like heads for a while, right? So that's not 1 out of 2. That would be like a 10 out of 10, or however many times she flipped it at first, right? So experimental probability is not always going to be exactly what the theory says or what we think is going to happen. So that being said, let's make some observations. We're going to be scientists today. I want you guys to take the coin that I asked you guys to get, or if you need to go run and get one really, really quick. And I want you guys to flip that coin 10 times, okay? You're going to flip the coin 10 times, and then you will observe the number of times heads is flipped. Okay? You will record your data into the Google form. Okay, so we're going to share with you guys a Google form sheet. Once you've flipped all your 10 times and recorded your data, you're going to go ahead and put that into the Google form. Okay, you can use the draw sheet for right now.
Also, if you don't have a coin, the next slide on the slideshow has a link for a digital coin.
Good, thank you.
Yep.
So you can use a digital coin if you're like, I cannot find a coin in this house at all, okay? But you can get a coin, flip it 10 times. You can already go ahead and start doing that. Okay, we want to have you guys a little active today. Flip that coin 10 times. In your draw sheet, you should have something that looks like this, where you can write down your answers, what you got, and then I'll share with you guys that form here.
Okay, bye.
Are we starting now?
So right now,
You are flipping coins.
flipping coins. Flipping coins.
Like I said, if you don't have one, I can show you just real quick. Let's see. If you don't have one, then you can go to the next slide in your slideshow, and there's a link. Oh, there's not for a coin. There's a link for a 6-sided die, and there's a link for a spinner, but it looks like we don't have one for a. I bet if you just Google one there.
Yeah, do you want to just click a new tab, Mr. A?
This stinking. Okay, let's see.
Flip a coin.
Digital coin flip. There we go. Look at that. Digital coin flip. Just flip a coin. There you go. Heads, tails, heads. Flip again. See, so all you have to do is click and you get a. Oh,
Yeah.
heads. Heads. I got heads 3
In
times.
person. So, if you guys have a coin, recommend the real thing.
Oh, yeah.
And if you, yeah, anyway, for part of your assignment later, you can use a die if you have one in a board game box or cabinet or something. So this link right here in the chat, guys, I know we're talking a lot. This link in the chat, once you get all your flip results, you're going to go to this link. Oops. Yeah. To submit your answer.
That's the Google form, right?
Yes.
Do you want to open that up to show them what it looks like?
Yes. And actually for now, guys, once you have your results recorded, you don't just hold off on putting it in the form for now, but I'll show you what it looks like. Okay. Share screen. Okay, so this is what your draw sheet looks like. Hopefully you flipped your coin 10 times or are doing that now. You can put in your answers here, And then on the next slide, this is the link that I sent you guys, this Google form link. So you guys are going to do an assignment. Okay, you're going to roll a 6-sided die, and you can use a virtual one or a real one. And then you're going to use a spinner, and then you're going to take this info that you got, the coin flipping, the die rolling, and the spinner flicking, and get those 3 results, probabilities, and put them into this link. That's how you're going to submit your homework. Okay, and I'll talk more about that in just a second. But take about 1 more minute to get your 10 coin flips, and then we'll talk about it. And we'll be done.
Don't leave yet, Anthony. We're not quite done. Hang around for just another minute.
Yeah.
If you could. We'll be done before your next class starts, so.
And if you want to, I saw some people put how many heads they got in the chat. You can do that. You can go ahead and do that now if you haven't already, just to see what we got. Curiosity. Sorry. Six heads and 4 tails, 4 heads, 5 heads. Okay. Nice. So good. So let's say, so I'm just going to make this up for now. So let's say I flip a coin several times and I get 7 heads. I put that 7 there because I saw 7 heads. Based on your experiment, what's the probability of getting heads? So if I'm just working off this probability that I figured out, I'd say, well, I got 7 heads out of a total possible of 10. So I did 10 flips. That's the total. It's going to go in the bottom. Total. Number of attempts and how many times it occurred. So it occurred 7 times out of 10, so 7/10. As a decimal, that would be 0.70, or as a percentage, that'd be 70%. This is just for me, right? That's the thing, is it's going to be different for each person because they're going to have their own results. So whatever you guys get, if you get 6 heads, 5 heads, like some of you guys said, you put that over here. Out of the total times you flipped it, yours will say 10, because we're all flipping ours 10 times, and then you write your decimal and percentage. All right, so once you've got that, here is your assignment. Dun, da, da. No, you guys were just stoked. So, so today we're doing something a little bit different. We're going to be doing this experimental homework. Okay, so you follow the link that we posted there in the chat, and I'll post it on your classroom stream as well for my class. And I want you guys to, you've already done the coin flip because you were in class today. You're going to do this task right here. Okay.
It's yellow.
Yeah. I thought it might be a little bit. Right, let's try that. There we go. All right. Task 1 and task 2. So you're going to roll a 6-sided die. So you can use this virtual one here. If you don't have one at home, I like to use the real thing. So if you have a die, you can use it. Otherwise, just roll online. And it's going to have you roll it 10 times and see how many times you get the number 4 Okay. And then you're going to do a spinner. And you can use an online spinner. Use this one here. And you're going to do that 10 times. And write down the number of times.
Instead of writing down or keeping track of how many times you spin my name, do it for Mrs. Cole's name, because the Google form is one that the entire 7th grade will be using. And we're trying to figure out how many times everyone got Mrs. Cole's name. So when you do the spinner, keep track of how many times you get Mrs. Cole's name on the spinner.